Hi everyone, I'm Suvarna Joshi and I'm presenting today with Anmol Handa, and the topic of the day is future of databases. Let's look at centralized databases. One of its primary feature is that there is a computer system or a server located in a single location. This provides remote access to all the users in the network and also ensures that the backup is easy, and because of the single location, the maintenance is easy too. One of its drawback, although, is that it creates bottlenecks, which means that the incoming requests are much more than the outgoing responses. Talking about distributed databases, also known as decentralized database, its primary feature is that it consists of distributed storage systems and multiple processing units. It is scalable across multiple networks and it uses fault-tolerant communication through consensus. Apart from that, it uses replication and duplication. The difference is that in replication, it just creates copies of data through multiple storage systems, whereas in duplication, it consists of a master data table, which is used for all the functions, and other storage system just contains copies of the master table.
So let's see the technology forms of distributed database management system. The first one is the peer network data stores, where any computer can be used as a storage node. It uses error detection and correction techniques to recover damaged files, and the examples are BitTorrent and Freenet. Secondly, the SQL distributed data warehouses, where the systems are designed by major vendors to allow massive parallel processing of analytics-oriented tasks. Thirdly, the Hadoop, which is an open source software that runs applications on clusters and provide massive storage processing power to handle limitless parallel tasks. Moving on, NoSQL is also considered as a non-relational distributed database management system, which is horizontally scalable and designed for real-time web applications. The examples are MongoDB, Apache Cassandra, Redis, Google Bigtable, and CouchDB. Then NewSQL, which is a relational distributed database management system, is combines the best of relational databases and NoSQL databases properties. The major examples are Clusterix, Google Spanner, and VoltDB. Lastly, the distributed ledgers, which leverages cryptography and maintain consensus about the existence and status of shared facts, is also referred to as shared ledgers at times.
Some of the properties of a distributed ledger is that database is consensually shared and synchronized across networks, which eliminates the need of a central authority. Data is also securely and accurately stored, which makes it harder to attack. Each participant at each node owns an identical copy of the database. Looking at the figures, the first figure of distributed ledger shows the difference between distributed ledgers and centralized decentralized networks. This means that if one node in distributed ledgers is down, then none of the other nodes are affected, which is not the case in centralized or decentralized. The second figure explains the blockchain technology and the difference between a centralized ledger and a distributed ledger. A blockchain is a tamper-evident shared digital ledger that records transactions in a public or private peer-to-peer network. Distributed to all member nodes in the network, the ledger permanently records in a sequential chain of cryptographic hash-linked blocks the history of asset exchanges that take place between the peers in the network. All confirmed and validated transaction blocks are linked and chained from the beginning of the chain to the most current block, hence the name blockchain. The blockchain thus acts as a single source of accurate information, and members in a blockchain network can view only those transactions that are related to them.
So what is blockchain? Well, the internet is built on data. Most websites out there work with and hold this data by running on databases. Facebook's database holds information on every user, every post, every like, and every comment. Another example, your bank uses databases, including a ledger of transactions determining how much money your accounts have and where it's all been going. But most databases are centralized. This means that they are sort of in a central place or controlled by a single person or company, so frauds, hacks, disasters, censorship, and manipulations can occur if the central place or controller is compromised or corrupt. Blockchain is decentralized. Transactions are recorded not on just one computer, but on many, many, many computers. So if a hacker breaks one computer or phone, The other computers remain secure, and they also notice the changes and force them to be corrected. A blockchain is indeed a growing tower of blocks, but not quite as easy to topple as this one. This is simplified, but each block of data contains a hash, a complicated string calculated from the block before it. If a block changes at all, its hash must change. This means that if data in earlier blocks is ever modified, the bad data is really obvious. These chains can get quite large, of course, which is one of the reasons Bitcoin forks now and then, but certain pieces can be pruned off over time without compromising the system, unlike our tower, which probably wouldn't hold up quite as well when pruned. The most famous technology based on blockchain is Bitcoin, which basically started the rage. But this is early, like the internet in '93, and the craziest innovations are still ahead.
So let us see how the biggest implementation of blockchain, that is Bitcoin, which has revolutionized the market, works. So it is developed by an individual whose pseudonym is Satoshi Nakamoto, and Bitcoin is basically a distributed ledger that holds value of any user's money. Each user can access their account details through the shared database without having to pay for it and maintaining the anonymity. Also, you can spend at will without asking permission from a third party. Through cryptography and peer-to-peer ledgers, copies are made that can be checked in case of issues. Now we'll have a look at the how bank ledger and Bitcoin ledger varies, and as we see, they just vary in terms of the address, which is hidden in Bitcoin and shown in bank.
So let's look at some other examples. One of them is Hyperledger, which is an open source collaborative effort to advance cross-industry blockchain technologies. This means that companies from different sectors of businesses work together without any middlemen. It is a distributed private blockchain network which consists of about 130 members and 8 ongoing projects, amongst which a hit is Hyperledger, Fabric, and Composer project. Consensus and membership services are plug and play, which means customizable as per a company's requirement, and it ensures confidentiality, resiliency, flexibility, and scalability. Another example is Ethereum, an open source software platform that enables developers to build and deploy decentralized applications. It is a distributed public blockchain network. Instead of mining for Bitcoin, miners work to earn Ether, a type of crypto token that fuels the network. This company helped discover the term smart contract. A smart contract is a programmable piece of code which is executed when certain conditions are met. Many decentralized autonomous organizations use Ethereum for their business.
So let's see some eye-catching features of blockchain. So the first one is the integrity and transparency brought by blockchain. The second one is that blockchain supports only read and write operations as compared to the CRUD operations supported by a relational database. Thirdly, the validating and writing, which blockchain allows. And lastly, the enhanced security. But there is one drawback of blockchain, which is the performance. Due to enhanced security, the performance is to be compromised here. Now let's see where blockchain is already being used and is planned to be implemented in future. The first one is the banking and insurance sector, where the security is the main concern. Then secondly, the smart contracting industry, where the manual contracts need to be converted to the smart contracts or the digital contracts. Thirdly, the Internet of Things, which is also prone to security defects. Then comes the file storage, where a more secured form of file storage is needed. Third, then the supply chain management, where better trackage of shipments and orders is required. And lastly, the protection of intellectual property, where the ownership of data needs to be implemented.
So let's take a look at which database is right for your application. A relational database is used when systems with better performance, faster, and reliability is required, where stored procedures ensure smooth outputs. Blockchain and distributed ledgers are preferred when either robust fault-tolerant system is required or secure systems with integrity or smart contract that ensure seamless transactions between users is required. Even between distributed ledger and blockchain, distributed ledger is preferred, which is a subset of blockchain when security is not a major concern in the application. The biggest implementation of blockchain database, BigchainDB. It is an example of modern distributed database. In it, its feature is that it is compatible with both traditional as well as blockchain stack. This means that it can be used for centralized as well as decentralized processing systems and file systems. When adopting blockchain into your organization, it's not necessary to replace your existing databases and associated processes unless your previous system is paper-based. Instead, you can integrate and improve by obtaining metrics and planning an expansion as Spotify and Chase did.